guys, today we are going to do February-March 2023 paper 4. It's a chemistry paper and it's variant 2 paper 42. So let's try the first question together. You can see is that first question they like to ask about things like general chemistry. The question is about the gases in clean, dry air and gases found in polluted air. Okay, they want to find the gases in clean, dry air and the gases they found in polluted air. So what gas found in the clean air that contributes to global warming? If I ask for global warming, it's definitely two gas. Okay, it's either CH4, our methane, or CO2, our carbon dioxide. But what is in our clean, dry air is we have 78% of nitrogen, 21% of oxygen, and 0.04% of carbon dioxide. Actually 1% of others, which includes carbon dioxide and also our argon gas and others. So for this case, definitely if you want to find in the clean dry air, it's definitely carbon dioxide. And as mentioned, nitrogen is 78%. Okay, the next question, if we need to remove sulfur dioxide from full gas desulfurization, we need to use calcium oxide. This is actually under our chapter 10, chemistry of the environment, because sulfur dioxide will actually cause acid rain. So acid rain mainly caused by nitrogen and sulfur dioxide. So in order for us to remove our sulfur dioxide, we will use either our flue gas desulfurization, which is involve reacting sulfur together with our calcium oxide, so I can remove them, or we can actually use fuels with actually low level of sulfur. Okay, the next one is our nitrogen dioxide in our car engine. What is the name of the equipment? This is quite special and it's quite very famous in the question. We call them catalytic converter. So catalytic converter have few important things in the exam is that you need to know their honeycomb design so that they can increase the total surface area by reacting with the gases. Other than that, they are using the platinum, which is the transition metal, so that they will be less reactive and it will be very useful. Okay, so which one they will diffuse quickly? This is very famous question. Every time you see diffuse quickly, this is definitely about our molecular mass. Okay, so I don't want to waste time by checking periodic table. You should know that carbon is 12 gram, okay, and oxygen is 16 gram, carbon 12 gram again. So this one 16 gram times 2 because there's 2 oxygen. Definitely is heavy already, right? And 12 gram add with 1 gram times 4, and this is 14 gram add with 12 gram times 2. This is, I really forget, but yeah, let's see. Sulfur is 16. So this is how you guys see 32. 16 is always the smaller one is always the proton number, so the mass is the bigger one. Okay, so this is how you guys can see them. Okay, so this should be 32 gram add with 16 gram times 2. So very obvious, you can see the lightest will be our methane gas, CH4. So they ask you why. I already told you earlier, right? So relative molecular mass. We call them relative molecular mass because supposedly we don't write gram there. Okay, but I write gram because I'm quite used to them. But actually they are just comparing with the mass of carbon, so we don't have to write gram there. Carbon monoxide adverse effect. Please be careful. Carbon monoxide is actually a neutral gas. They are not acidic. Only carbon dioxide is acidic. But how come they are bad for our human health? Is because of the toxic. Okay, it is a toxic gas. So why? Because they will actually bind with our hemoglobin, so they will cause oxygen unable to bind with the hemoglobin, so we will have lack of oxygen. So kind of like suffocation, yeah. So carbon dioxide is a reactant of photosynthesis. So name the two products of photosynthesis. Okay, if you know, carbon dioxide is actually adding with water, so you can form your favorite glucose and also our oxygen gas. So students used to think that it's very difficult for them to actually balance, but for me it's very easy. Just 6, 6, all the way 6. Because why? This is actually 6 carbon and 6 water, if you realize that. That's how I actually open them up and I memorize after that. So very simple. They want name, so please be careful whenever they ask for name, not chemical number. So this is glucose and oxygen. Okay, let's see the next question. This is a dot cross diagram. Students tend to get very confused. They don't know how to do the dot cross diagram. So what I do is that I find their group first, group 4 and group 6. Okay, I know because I'm already very familiar. So if you're not sure, you just go to your periodic table and find. Okay, group 4, very simple. It means that they have 4 valence electrons. So what I usually do is 1, 2, 3, 4. It means that all of them is like insufficient, can see? They need one more partner, right? So don't carry it first. Let's see about oxygen then. Oxygen is 1, 2, 3, 4, 5, 6. Another 1, 2, 3, 4, 5, 6. Why do I do so? Is because I am purposely sharing them one. Okay, you need to know covalent bond means that whenever I give you one, I must also take away one from you. That's called sharing. Today you bring a lunchbox to the school, you will share a nugget with them, and your friend need to share one hot dog with you. That's what we call as sharing, right? So these are lone pair. Lone pair means that we don't need to pair with anyone anymore. So this is known as lone pair. Okay. So lone pair, yeah. So you can see this is quite single and set. So what I do, I combine them together at this point together. It doesn't matter where you want to put them, okay? So combine them together. I share one, I give one, right? So if you were to draw the bonding, basically carbon is like that. Whenever you have 2 electron, it means 1 bond. Okay, 4 electron, it means 2 bond. Usually it's cross and dot. So 3 electron, sharing, 3 bond, triple bond. So you can see this is, so you can see this is 4 electrons. That's why it should be 2 bond. And then O. So usually people will just ignore the lone pair, but I can show you here. They're just like this. Very simple. Okay, next question. So what type of bonding is in the elements of lithium, sodium, potassium, which is the group 1? So if you know group 1, you should know that they are alkaline metal. So from the term metal, if they are alone, they are definitely metallic bond. Usually students get confused. They will ask, hey, isn't that ionic bond? No, ionic bond is whenever metal and non-metal. So this is metal, just metallic bond. Okay. Hydrogen gas, very simple. I like this the most. We have 3 types of colorless gas, okay? Hydrogen gas, usually I use lighted wooden splint, okay? So you can see I purposely write the H there so you can memorize easily. That is lighted wooden splint, okay? The result is that it will give you a pop sound. Understand? Okay, very simple. If I ask oxygen how, I'm just giving you extra, yeah? Oxygen, O. So oxygen is very useful for glowing wooden splint. Why? Because they will help them to relight. If you know, right, those candle, I used to like those like very nice perfume candle. So perfume candle, they will give you a cup to cover them. So when you cover them, they don't directly ignite them. It takes time. Reason behind them is because oxygen is also very useful for combustion. Every time you see the word combustion, it's definitely oxygen, yeah? And the last one, carbon dioxide. So to test carbon dioxide, very simple. Just use lime water. Lime water will definitely turn cloudy. Reason of them turning cloudy is because they will turn into calcium carbonate from calcium hydroxide. Okay? So strong alkaline, definitely 14. I'm afraid that some of you still don't know. We have 1, 2, 3, 4, 5, 6, 7. I like to put this 7 here, and 8, 9, 10, 11, 12, 13, 14. Actually, we have 14 pH number. Yeah, a lot of people don't know. Since 7 is the neutral, so I like to do this way. Okay, this is neutral. So those that are near to neutral is weak lah. This is weak acid. This is weak alkali. Okay, so the one that's furthest away, strong acid, strong alkaline. Understand? So if I really want to confirm the pH solution, we can actually use the famous one, universal indicator. Okay, so using the state symbol, you can see they want sodium and cold water. Okay, sodium can react with cold water because sodium is quite reactive already, right? Because they are the third period in the group 1, right? How I memorized LINAC. Lithium, sodium, potassium. So sodium definitely is a solid. They get them out from the paraffin oil. If the exam asks why, it's because they are too reactive. So we must keep them in paraffin oil, and they will add with water. Water is always either solid, liquid, or gas state. So I should get sodium hydroxide solution and hydrogen gas, because you can see the fizzing things, right? So to get them balanced, you can see here I am having odd number of hydrogen, so I times 2 here. So I can get 4 hydrogen here, I times 2 here, and then I times another 2 here. So it should be balanced. So sometimes they like to ask you what solution you're getting here. You can get a alkaline solution, or you can say that you get a base solution. Okay, reason of you writing base is because they are pH more than 7. Okay, whenever you see the same type of element but different type of atoms, you can see the atoms is different, right? But they are the same element, because element is the same type of atom, I mean like together, right? Like lithium and lithium together, right? So it's always known as isotopes, because the word iso, it means same. Okay, so let's see here about the proton number. We just follow this one. Proton number is always fixed, so if you really forget, you go for a periodic table. But actually there are 3 lah, proton number of 3. You can see here. So we go for here, and you just have to write your proton number of 3. No matter what isotope you are definitely same, because proton number is determine what element you are. So this is 3, but the nucleon, this is under nucleon. A lot of students will get confused. This is nucleon number. Why? Because I memorized them inside nucleus. So inside nucleus, they will have my proton and neutron. So outside is our electron. So very simple lah. Nucleus, nucleon, neutron is always neutral. Okay, so that's why 6 minus 3 you should get 3, 7 minus 3 you should get 4. If you don't understand, you have to go back to your basic and learn again what is the proton and neutron, yeah. And this is the positive. So whenever you see positive, right, please be careful. It's not that they are more proton, or like they don't have electron at all. You must understand one concept is that neutral means proton and electron the same. It means that this is for atoms. So you can see this is the same 3. While for whenever you are positive, it means that your proton is less than your electron. Okay, when you're negative, more than my bad. When you're negative, proton is less than your electron. So I want you to keep in your mind, only electron is changing. Proton is never changing, because you will either lose your electron or you will gain your electron to become stable. So lose means that I can either make them into first shell of 2 or second shell of 8. Lose and gain are trying to achieve the same. So for this case, I am positive 1, so I lose 1. So it's 2. Okay, if you really don't know how, very simple. Positive 3, negative 3, you are 0. Can see that? positive 3, negative 2, 3 minus 2, positive 1. Okay, but in the exam you don't have to write the positive negative charge lah. I'm just showing you so you can understand them well. Okay, for this relative atomic mass, it's very simple. MR formula, relative atomic mass formula, is mass 1 percentage 1 plus mass 2 percentage of abundance 2 divide by 100. Divide by 100 is because the percentage is 100. So you can see if like 6 times 10 plus 7 times 90 divide by 100. So it's 690 divided by 100. So you should get 6.9. So answer is 6.9. If you are not sure, right, you go and check your periodic table. Our periodic table always give you whole number except for chlorine. Okay, but you can see it's 7. It's because 6.9 is very close to 7, right? So this is how they get the relative atomic mass. So the next one is that they want you to show the electronic configuration of our potassium. So potassium is the third shell. Okay, so fourth period. So they should have like 2, 8, 8, 1, and supposedly 2 and 6 for oxygen. So 2, 8, 8, 1. So what we do is this one we will remove to 6. So it will turn into 2, 8, 2, 8, 8, 2, 8, 8. This is what we call as donating and accepting your electron. So when you donate 1, you turn into positive. So don't forget to draw the last shell. A lot of students will miss this out because they will thought that it's full, right? But no, actually there are 3 shells needed. So I'm quite lazy. I just will copy and paste here. So as per mentioned here, this is like a cross. So usually what I do is 1, 2, 3, 4, 5, 6. So these are lone pair. They don't need anymore. Another 2 is shared from the potassium. Can see that? So this 2 is known as lone pair. Okay, total everyone will have 4 pairs because 8 electrons, right? So question 3, Haber process is my favorite. Haber process is to make ammonia. Another one we call them as contact process is to make sulfuric acid. Okay, I just want to remind you so that you don't have to revise again and again. By doing just one past year question, you can revision a lot of things, right? So later they will tell the process and the things needed. I will write for you too. So nitrogen is coming from air because nitrogen is 78% in the air, right? And hydrogen is from methane. Some people tell me that it's from water, but actually from methane is easier to get. Okay, so what is the symbol of changes? I mean the triangle and H. In chemistry, in physics and biology, whenever you see the word triangle, it means change. So for this case, it's actually enthalpy change. Enthalpy change means that the changes in energy. So you can see the forward reaction is exothermic. That's why the negative, because why? Reactant is having higher energy than our product. So if you were to draw the graph, it will look like this. Okay, reactant is higher, so product is lower. And this is known as the enthalpy change from the reactant to the product, and this is known as the activation energy. Okay, you must be careful. So if you go for endo, it's just the other way around. I'm just giving you again the revision, yeah, because this drawing is quite important. So sorry, it should be lower and they go up and this way. So you can see is that the activation energy is quite high and the positive enthalpy change. Okay, so how do we know the value shows that it is exothermic? Actually, it's quite simple, you see. You just have to say, oh, because it is negative. Because the value is negative. It's very simple, right? So say the condition of Haber process. I always remember is that Haber process need very high temperature, 450. Pressure need to be very high as well, 20,000. And the catalyst always we use iron filling. So if you were to do our contact process, usually we will use like oh, because this is Pascal, that's why. Okay, usually I will write 2 atmospheric pressure, 2 atmospheric pressure, sorry, yeah, 20,000, sorry. So basically, if you were to do for our contact process is also 450 Celsius, but it's only 2 atmospheric pressure. It's very simple. Because contact process is acid, so I always memorize that it's very dangerous. And they are using vanadium 5 oxide. Simple. Okay, so let's see here. Must be careful about the difference between rate and equilibrium. Okay, equilibrium, right, means that the forward reaction and also the backward reaction. Okay, so this is either the forward or the backward. Okay, and for the effect of rate, right, rate of reaction is just very simple. You will affect by temperature, catalyst, pressure, concentration, and you're just up or down, like faster or lower. We don't care backward or forward. Okay, so you see pressure decrease, definitely you are decreased lah, because there is like less collision, right? Temperature increase in kinetic energy, more collision, right? Okay, so no catalyst, definitely your reaction is decreased. But you can see here is that whenever they ask for ammonia, production of ammonia in equilibrium, means that they want a forward reaction. So if I want forward reaction, if my temperature increase, it will decrease. Because why? Temperature increase, it will cause favor in endothermic. Because I always remember exothermic is an fireball. So fireball will only react whenever the temperature decrease, because they will help to warm up the whole temperature, right? They will produce a lot of heat because exothermic will release heat. Okay, the pressure here decrease. Okay, let's see here how many number of moles here. 1 mole and 3 mole. So 4 moles here, and that is 2 moles here. So whenever your pressure decrease, right, they will go for the higher number of molecules so that they can increase the pressure back. You get what I mean? So that's why this is decreased. So always remember, only when your pressure increase, they will need to go to the lower number of molecules. Then you will produce ammonia a lot. So there's no change whenever you have catalyst or not, because it's just forward and backward, right? So must be really careful. The rate is different with equilibrium. So if you forget about this, you have to do your revision, yeah? So this is under the chapter of chemical energetics. Okay, so chemical energetics in chapter 5. So you can go back to chapter 5 and reread again to learn about the difference between rate of reactions as well as our equilibrium. Because if you check on that, you can see, oh sorry, it's under chapter 6. Chapter 6, the 6.1 is about like the chemical change and rate of reaction, and 6.2 onwards is about reversible. So you can learn again about that. That is under chemical reaction. So let's see, this is a 3 marks question, long lost 3 marks question, right? Usually it's like very less marks. So the collision theory about the why increasing temperature can increase the rate of reaction. So collision theory means that they need to know how the collision is happening, right? So what you do is basically every time, no matter what chapter, no matter what subject, increasing temperature will cause increasing in one energy, which is our kinetic energy, because you can move more, right? So increasing temperature, it will cause increasing temperature will cause kinetic energy of particles increase. So whenever kinetic energy particles increase means what? They move more, right? So particles will have higher frequency of collision between each other, or you can say between wall, okay, each other and walls. So whenever you have more collision, what happens? There will be also, because of the increase in temperature, okay, the particles will also have more energy than required activation energy. Hence, more successful collision. Because you need to know, whenever you have more frequency of collision, it's not really like 100% helpful. But successful collision is the main thing, that is the main important thing. It means that today you try really hard in your exam. You really try hard, right? You fill everything in your paper, but you won't get 100%, right? Because not necessarily successful. So it's very important for you to know successful collision is different with the frequency of collision. Frequency is like how hard you try, right? So successful collision is how successful you are. Okay, so let's see about ammonium sulfate, about the acid used in ammonium sulfate. So whenever you see sulfate, we have only 3 acids in our syllabus: nitric acid, hydrochloric acid, sulfuric acid. So H2SO4. Why H2SO4? They ask you to write formula, not name, yeah? So what is the use for ammonium sulfate? Very simple. It's always used for fertilizer. Okay? So percentage of composition of the nitrogen. So you have to go for your periodic table and find out their mass. But I already memorized. Nitrogen is 14, hydrogen is 1, sulfur is I think 32. Yeah. Oxygen is 16. So basically 14 plus 4 times 2, because there's a bracket there, right? Plus 32 plus 16 times 4. So this is the total MR. So it put at the bottom, and this is the MR. Okay, so what you do, you should be able to calculate the MR as 132. So nitrogen itself is only 2 nitrogen inside. Please take note, there's 2 nitrogen, don't just take 1. Okay, so there's 2 nitrogen over NH4 2 SO4. So 2 times 14 divided by total of 132. Answer should be 21.2%. It's quite less, to be honest. So let's see, metal in brass. Brass contains zinc and copper. This one I can't really help you. You have to memorize. Okay, mixture is always alloy. Okay, alloy is actually a mixture. A lot of students don't know. What is the difference between mixture and compound? Compound is that you must have a chemical reaction, which is like, you see, you have loss of electron, gain of electrons. But mixture, no need. You just high heat and then you just dissolve, melt them together and combine. This is alloy. So property of metal that can be stretched into wire. Wow, my students used to get very confused with this one. This is ductile. So if you can shape, put into any shape, that one we call as malleable. Okay, there's a difference between malleable and ductile. So sorry, this is ductility, malleability, because they ask for properties, right? So if you're very ductile, means that you can pull as wire. This is especially like our copper. They are very useful and they are ductile. So name the particles that is responsible for conduction. So whenever you can conduction, right, means that you can conduction of electricity in chemistry, physics, biology. Every time you see science or bio, very rare, yeah. So it's always because of the free moving electrons. But they ask for the particles name, so you don't have to say free moving. Understand what I mean, right? So this is the physical and chemical properties of our transition metal element. They're very, very famous. High density, high strength, can form colored compound, have various oxidation state. Other than that, they can also act as catalyst. Act as catalyst is a chemical properties. Okay? Wow, this paper very good. They tell you everything you need to revise already. Another physical properties, high melting point. They like to compare with our group 1. So if you were to compare, right, group 1 is lower density, okay, softer, okay, and very reactive, but that one is not really useful. So yeah, just these 2 things. And oh sorry, lower melting point and boiling point. Okay, You can just write melting point lah because they are metal, right? Yes. So for this hydrated copper sulfate, this one very famous also. It exists as hydrated crystals which contain water molecules. So state the term that water molecules present in our copper sulfate. So very simple, CuSO4, remember there's a dot, 5H2O. So if they ask for cobalt chloride, is CoCl2 dot 6H2O. That is hydrated lah. You can actually get dehydrated by just removing the water, okay? So the water of the hydrated one, they are initially dry. When they are dry, they are white. So when they are wet, they are blue. While for this one, when they are dry, they are blue, and when they are wet, they are pink. So yeah, pink. I write for you. Plus 6H2O. So this is blue. When they are dry, they are blue. Yeah. So they ask for the hydrated formula. Did I write wrong? Oh, sorry. Hydrated formula should be written here. They ask for the term of the water molecules. So it's just water of crystallization. Okay. It's a kind of like water of crystallization lah. They just call them in the hydrated crystal. Seems very special, right? The name. Oxide of copper oxide. Copper oxide actually, if you know, they are under basic. Okay, they're under basic. And how I know is that because you have to remember lah. Okay, so the Roman number 2. Always remember whenever you see this Roman number 2, Roman number anything, like example copper 2 sulfate, right, or cobalt 2 chloride, right, they like to write this way. It means that the oxidation number. It means the oxidation number is positive. Okay, so you can see here the number of moles of the copper nitrate is 0.02. What is the mass of them? So very simple. We have a few formula. First is number of moles equals to mass divided by mR. Second formula is number of moles equals to concentration times volume. Third formula is number of moles equals to volume of gas divided by 24 dm cube. Okay, very simple. So you can see if you need mass, use the first formula. MR, you need to find the MR out. And yeah, so just find the MR out. Copper, I didn't memorize everything, so that's why I need to find like you. 64. Nitrogen is 14, oxygen is 16. So yeah, 64, 14, 16. Okay, so how we do? Basically, number of moles 0.02 equals to mass, the one that I need to find, divide by 64 plus 2 times 14 plus 3 times 16. So answer should be 0.02 times 1.188 equals to your mass. So mass is 3.76 gram. Chemistry is nice. They always write unit for you already. Okay. So let's see the next one here. The total volume of gas. So volume of gas, very simple. Use this. 0.02 equals to volume of gas divided by 24 dm. Very simple. You see, a lot of students say, hey teacher, I don't know the calculation, please tell me. Write down these 3 formulas, then you can do everything. Okay, one moment. They asked for the gas. I think I misunderstood something. You have to look here carefully. They asked for the total volume of gas, which means who is gas? Nitrogen dioxide, carbon dioxide, oxygen. Okay, so basically you can see number of moles, this is 0.02. So this should be also 0.02, this should be 0.04, and this should be 0.01. You know why, right? Because of the ratio, because of the number, this one. So when you are 2, you are 0.02. So you are 1, 0.01 lah. Very simple. You are 4, 0.04 lah. Right? If you don't know how to do, you can cross multiply. What do I mean? 2 equals to 0.02 mole. So if 4 equals to x, I don't know. So 2 times x, 4 times 0.02, so 2x equals to 0.08, x equals to 0.0, is it correct? Divide by 2, so x equals to 0.04. Yeah, correct. I got confused. So yeah, so basically you can see the total number of moles of gas is 0.05, right? So basically 0.05 equals to volume of gas. You know why 0.05? Because 0.01 plus 0.04, because they want the total volume times 24. So volume of gas equals to 1.2. Oh, simple. Simple equation. Okay, powdered reduced carbon dioxide. Very simple, because aluminium is more reactive. So whenever you're more reactive, you can simply just displace your less reactive one. And it's very simple because they even give you all the number. So Cu is 2 plus, O2 negative, so CuO. Aluminium is 3 plus, O2 negative, so Al2O3. Sorry, my bad, haven't. Aluminium solid, add with copper oxide. They didn't ask for state symbol, so it doesn't matter. Copper oxide, get with aluminium 2O3 and Cu. So balance them, yeah, times 3 times 2 times 2, 3. Can I understand? Okay, let's see the last question. I think, oh yeah, last question. So fast, right? So same homologous series with similar chemical properties. They always say that similar, because similar and same is not the same. Same is 100% same. Similar is very look alike. So they have same functional group. Okay, if you forgot this chapter, you have to revise. Okay, functional group is like example, alkane is all single bond, alkene is all double bond, and alcohol is the one with OH, and carboxylic acid, I always remember COOH, but actually if you want to write nicely, it's like this, COOH. And ester is COO. If you want to write nicely, it's COO. Okay? So homologous series where propanoic acid belongs. Name. So name is carboxylic acid. And if they ask for the general formula, CnH2n plus 1, COOH. It seems very difficult for you to memorize, but I already memorized with my own way, which is alkane is you see, I try with 2 to show you lah. Okay, 1 2 and 1 to show you. 1 2, and then this is definitely H and H. So every one carbon there's 2 H, can see? And there's extra of 2 H for alkane. So plus 2 lor. So this is for alkane. That's how I memorize. Okay, alkane. And alkene, how? Alkene cannot be 1. So alkene usually is 2. And 2 carbon, 2 hydrogen, can see? So it means that 1 carbon, 2 hydrogen. And there's no more at the side. So that's why always 1 carbon, there will be 2 hydrogen already. Okay, but alkane cannot be alone lah. So, but still the functional group is CnH2n only. Okay. OH also very simple. You can see 1 carbon, definitely 2 hydrogen, so CnH2n. Okay, and then there's definitely add 1 H, so plus 1, and another one OH. So very simple. You need to understand the concept, so everything is very simple for you already. Same goes to carboxylic acid. I try to put with 2. Okay, so very simple. CnH2n. Okay, also, but you can see they are carboxylic acid, so add with COOH. So C double bond O OH. I use another color. C double bond O OH, and this one is H, right? So what I do is that CnH2n plus 1, which is this side, and then COOH. So that's why you see or not? I forgot this one. Why my one is gone? Plus 1 and then COOH. Very simple, right? So yeah, if you go for ester, that one don't really have a functional group. So yeah, this is how you should do them. Yeah. Did I put wrongly here? Oh yeah, I didn't write this down, sorry. CnH2n plus 1 COOH. So once you get the concept, it's very easy for you to memorize. Okay, so it's not a problem, right? Let's continue. So propan 1O unbranched isomer, they ask you to name this isomer. Oh, this chapter isomer is all the same. We call them as, what isomer is that? Do you still recall them? They ask for the isomer. This is the structural isomer. Okay, so if you were to answer this isomer, since they ask unbranched, right? So very simple, you just change the position. Propan to O, very simple. Or you can name them 2-propanol. Okay, if you were to draw them, 1, 2, 3, because propan, usually I start with many, elephant, prefer, blue, pineapple, hexane. Okay, so propane is 3 carbon. So O H H H H H H H. If you ask me, can I do 3-propanol? Cannot, because if you put at the third one, right, it will still consider as one, the first one, because we don't care the starting or the ending. They always just calculate the smallest number. So you can only do 2-propanol. Okay. So they say that when you heat them, you can become decane and another product. Oh, sorry, you can form propane and one more other product. So propane, like the one I teach you to memorize, CnH2n plus 2. So C3H2n, which is 6 plus 2, so H8 lor. C3H6 here for propane. Because propane will plus 2, propane no plus 2 ma. So the last one you don't know how, never mind one, you just use 10 to minus 3 and minus 3. So 10 minus 6, 4. And 22 minus 8 and minus 6, you get 6. 8. My bad, my mathematics. So you can see what you get is alkane, alkene, and alkene. So for cracking, right, you will always get alkene and hydrogen, or alkane, alkene, alkene. So like cracking, always from the alkane, crack into alkane and alkene. Oh, I have little sore throat, so my voice is a bit special, right? And my running nose and hydrogen. So that is how, and I keep mentioning about this process already, so the name is cracking. If you want to add on catalytic also can, because they use catalyst. The catalyst is alumina or silica. Alumina is aluminum oxide. Silica is silicon dioxide. Very simple. Okay, so display formula of polypropene show 3 repeating unit. Very simple. Propene, right? 1, 2, 3. You can put the double one here or here, doesn't matter, because when you put here, I can also calculate this as 1. When you put here, I can also calculate this as 1. Yeah. So usually, right, whenever I done everything, what I do is I will try to how do I say? I will try to fold them down. So you can see I want to fold them into like carbon and carbon together. So since they want 3 repeating units, so usually, right, repeating unit is like that. I will fold this down. What do I mean by fold this down? This thing I put downstairs. CH3. Can see? So what I do, I just have to open up this thing. And this is the repeating unit. Understand? But they ask you to show the displayed formula. So how I show is, sorry. I paste one here. And I erase off this and this. Very simple, you see? And I copy another one. And paste one. So that's total of 2 already. 1, 2, 3. Ta-da! So yeah. this is how it will look like. Okay, and basically this is like the joint, and this must have a continuation bond, don't have to put the hydrogen inside. So this is the answer. Okay, what type of polymerization is this? Addition. Okay, we have two polymerization. One is addition, which is usually for alkene, and another one is condensation, which we have nylon, terylene, and protein. I purposely write protein next to nylon because they are very similar. If you forget, you have to go and revise back to your organic chemistry, which is the last chapter. Propanoic acid react with sodium carbonate to form salt. This is very simple. Acid with metal carbonate, guys. So acid can react with three things. Acid can react with alkali to form salt and water. Okay, acid can react with metal alone to form salt and hydrogen gas. Acid can react with metal carbonate to form salt, carbon dioxide, and water. So very simple. What is the salt form? So you just have to know what is the salt. Okay, because acid always will replace off. So sodium propanoate. Simple. Okay. What is the formula of the anion? Anion is the negative ions. Don't get confused. Cat ion, the T, can see, is the positive ion. Okay, so anion, because acid is H plus, right? And this is actually like propanoate is 3 carbon. So Na plus CH3 CH2 COO negative. Very simple, right? 1, 2, 3, 3 carbon. So what it means later, propanoic acid forms an ester when it reacts with ethanol in the presence of catalyst. So they ask about the suitable catalyst. Catalyst is usually use phosphoric acid. So acid, ester react with ethanol, you will form acid. So the ester form because propanoic acid and ethanol, right? I always teach my student ester is actually formed with alcoholic father and acidic mom. So what does it mean by alcoholic father? Your father, not your father. Usually father will drink alcohol. So I memorized that your name start with alcohol, ethyl. So acid, usually mom talk a very toxic one. Propanoid. So how I teach them to memorize is that the anoid and the ill. So always like your alcohol, starting will end with ill. Acid ending end with anoid. Very simple. So you have to draw. So acid is those always with double bond. So E1, 2 only lah, right? And then another O here, another C here, 1, 2, 3. Because propan is 3 ma. So your double bond is always with the acid. Then you are done. So far this paper I think is quite easy. You guys can take a look. If you have any question, please let me know. By the way, my name is Jamie. Nice to meet you.